Hello, everyone. Good evening, I guess, for you. Right, Setu? It's like 7.
Nice.
For me, it is like exactly lunchtime. And for
Oh,
Amy, you still have an
11
hour to go,
a.m.
right?
Yeah, I'm like 11 till 1 for this, and so yeah, it's going to be lunchtime after, I reckon.
Yeah, I should have taken lunch before. But welcome, everybody, and thank you for having me again. I heard it was the 3rd time. So that is pretty cool to be back. And I think today we also have a pretty cool story. I heard we have around 2 hours. So we might even have enough content for that. So that will be cool. Yeah, so my name is Henk Bolman. I'm from the Netherlands and I'm a cloud advocate. And before I was a Microsoft MVP and organized the global AI community, global AI bootcamp worldwide. And we also have Amy. Hi, Amy.
Hey, hi everyone. My name's Amy Boyd. I'm also a cloud advocate on the same team as Henk and specializing in AI and machine learning. And one of the nice things about this session is Henk's going to kind of approach this conversation from that AI developer stance. So Henk's well into the AI space, but realistically, integration into applications is super important. I have come from a more traditional academic approach into machine learning. However, I do like to say I'm not super precious about coding unless we really need that kind of use for AI and ML. And we'll kind of get onto that a little bit more later.
Exactly. Yes, so we have, I think, like 3 segments in this presentation. First, we're going to have a look at what AI actually is, where it came from, and how it works a little bit. Then we're going to look at AI ethics. Like what do you have to see there? Would you trust an AI? Have those kind of discussions. And then we will move into some more demos, like so how you can actually do this AI thing from a no-code perspective to a highly code perspective, where you basically have to code your own model from almost scratch. Shall we start?
Yeah, I was going to say, Setu, just a quick question. Is there a way that we can see people chatting in like a chat experience or anything? Yes. Yeah, could you send us the YouTube link? Mainly because we like to do this session quite conversational. And so we're going to ask you a few questions. And so we'd love to hear kind of your perspective. And some of the questions are really good fun and like nostalgic. So Henk, I'll take on moderation of YouTube. Let me just double check it's not going to play with sound. And yeah. Sure. Hi, everyone. Oh, there we go. Nice. Cool. So yeah, let's get started, shall we?
Perfect. So the first slide. So this was a little bit about our introductions, which we already done, but it is really about what type of persons we kind of are. So I come from a development background. I've been building websites for a long time. I think since I was 17, I've been building websites with from the time there were no frames and you had to do everything in tables to make it look pretty, and you had like Adobe that would chop up your images, and then you would have a perfectly non-responsive website because there were no mobile phones. And what we see on the left side of this picture, people with no idea about AI telling me I will destroy the world. I was kind of like that. Like, ooh, that AI. People were studying AI and robotics at university, and I was always like, what is this going to do? And then I started diving into it a little bit later, I think like 6 years ago. I really started to dive into AI, what it actually is, and how you can use it in your solutions. So then other people gave me like the model, and I would just implement it and run it. And later on, I moved to actually the last picture to actually try and make this neural network. And this happened to me like a lot, like dog, cat, and then basically it ended up that it was looking at the background instead of actually the cat that was in there, because I had no idea how to do my data correctly. So now I understand it, luckily, and I'm able to do it. And we're going to show you, I think, today in the last demo on how to actually classify your cat or your dog correctly. So with Amy, you had a totally different journey to get where you are now.
Yeah, so as I said, it was much more of an academic approach. So I was studying a pure computer science degree, so did a bit of everything. However, I had the opportunity to work at Microsoft's search engine called Bing, in which I met some incredible people working on at the time. So what was that, 2013? Working on big data and machine learning, and which was very, very early days, talking about things like petabytes of data, which now we just take for granted, but at the time was a real infrastructure consideration. And it was just fascinating. And they absolutely, it just showed me that that was exactly the area I wanted to be in. And so when I went back to university, I actually specifically kind of chose lots and lots of different lectures and exams and stuff based in machine learning, and it has given me a really, really good grounding. However, I would say that there's so much great content online that I don't necessarily think it's like, oh, you have to have like academic education in it. I think it just helps with kind of that bread and butter understanding, that basic understanding. But yeah, and so then from there, it's then become, I would say, much more ready for real life than it was when I was actually studying in academia. So realistically, lots of things have changed as well, which is interesting to see. I always talk about one of my modules it was called adaptive intelligence. What I now know of it as, though, is reinforcement learning. And so seeing that, we were studying that in 2013, that's still in research now, but we're starting to see applications in the real world being trialed and prototyped. Is fascinating to kind of see that progress. So yeah, slightly different approach, but ended up in the same place, right? And so me and Henk often like to work together on a project and stuff like that. There's always debugging sessions, it tends to be, with certain errors and packages changing and stuff like that. But realistically, that's what it's all about. It's all about working together with different skill sets.
Exactly, and it has been a lot of fun exploring AI and in this way. Also, when we were talking and trying to come up with the session, it was exactly the birthday of Windows 95, I guess.
Yes. So it's 25 years this year since, obviously we're in 2020, since Windows 95, and then we were just like, what? Like the idea that it's 25 years ago that was a thing was quite jarring. I was a bit like, oh my goodness, even I'm starting to feel old. And so yeah, I guess a question to you before we dive into the audience, I'm just going to paste it in the chat here on YouTube, is what was your first computer or memorable program that you used? So if you let us know, we'd love to kind of integrate it into the conversation. But Henk, what was it for you?
Yeah.
What was the first thing that you used?
The first thing I used was actually this 8086 computers. There's basically one behind me. I'm very small.
Oh yes.
But it is there. And there was this small game that you had like a figure, probably like 5 pixels now, and you had to push those blocks to a certain maze into a thing. I was still young, so I was like, I was in grade 4 or 5, so it was like 7 or 8. And my dad had those computers upstairs because he worked obviously in computers. And he learned me how to go to like CD and then the game and then enter, but I forgot all that. So basically, I went upstairs. The only command I could remember was typing "dear." So I could just sit there for like an hour and do "dear" and see the screen, have those nice green trails. That was my first experience with the computer. But then it moved on to kind of when I went to high school or middle school or whatever, like 12. It is in the Netherlands, and then we had these games like Wolfenstein and Doom, and we had this really awesome 386 computers with zip drives, floppy disk, big floppy disk, CD writer, and so on. No USB, and of course the turbo booster, which was really cool because why wouldn't you put it on still? Can't remember why you would put it off, but still that was it. And then the first internet came. Then it became like really interesting. Your computer, of course. Before we took these machines, you back to your dad, and he brought you to a room, and then you could connect your computers with these coax cables, with those terminators and T sticks. And if you had then like 30 computers, there was always one breaking. So you had to check and test them all. And mostly you were busy like 4 hours with connecting all the machines instead of actually playing a game. But then we had internet, and we would share like this internet with, I think, the 20 people, like a 28K8 modem.
Right.
Yeah, like the slow modem on the phone line, which was actually very expensive because you needed to have so much phone line for the whole day. So
also, like if someone was on the internet, like you couldn't use the phone, could you? So it would always be that. I remember that conversation happening in our house, and that noise it made as well. Like, yeah, just nothing ever in my life has made that noise since, I don't think.
No. So what I always did, we had this wireless phone, and I took the wireless phone up so my parents wouldn't find out that I was on the internet. They had to come up and pick it. Yeah. And I think I took my advice at least from a paperclip all the time. And that was kind of like the first kind of AI assistant I've seen, and I can remember someone that actually helped me doing my job, or doing what I was supposed to do. But yeah, let's forward 25 years. We have the cloud. Nice and not very blue, but on this picture it's very blue. So that changed a lot. Because now the cloud helps us brew AI, brewed beer. We have AI-infused toothbrushes. The last time you told me you had one.
Yeah. So that was potentially a lie, but I have one, an Oral-B that looks exactly like that. And it does have like Bluetooth, but I don't think it actually. I don't know. Like, to me, I don't see that it's using any AI. So it like times you. So if you brush your teeth for 2 minutes, it gives you 4 stars, and like there's a little timer thing as like a separate Internet of Things device, if we want to call it that it kind of communicates with. It's very impressive, and it's like a bit of a gamification. Yes, we are 2 adults in this house, but we still gamify brushing teeth. But and then if you like do it for like 1 minute 30, it's not quite as good. It gives you like 3 stars, and any less than that, it's like bad news, and it has like a sad face on it. So you don't want to upset the toothbrush, right? But I don't actually think I have the AI one. So I want to look more into this. Like, what is it that the Genius X does? Does it learn like brushing patterns or something? Like, I don't know. And then like give you advice. I'm not sure. So definitely one that I need to look into a little bit more after last time.
Exactly. Yeah. And last but not least, we have AI-infused toilets.
What is this?
Let's not dive into the toilets today, though.
No, let's stick with the beer.
Yeah, but let's dive into this AI timeline.
Yeah, no worries. So AI timeline, I think it's so interesting. A bit like what I was saying, like understanding the progression of what we've done before is so important in technology. Like we were always like, oh, what's the new release? What's the new shiny thing? What's the next big thing? But realistically, it all comes from steps that have happened before it, problems that we've foreseen or we found when we start to implement these things, and then actually solving those problems becomes the cutting edge, or the thing that is kind of the change. And so if you are getting into AI, or maybe you're already in AI, I think it's really, really important to understand where we've come from so that we can take that understanding, those patterns, those warnings, and kind of make sure that as we're progressing forward, we're keeping these things in mind. So the AI timeline, it can go even further back than this, but it probably becomes more general computing, in my own opinion. So before the Turing test, obviously with the very famous Alan Turing, who was a computer scientist and proposed that whether machines could be intelligent thinkers. And so the Turing test became a challenge or a test, I guess, yeah, as it says in the name, that allowed us to try to understand if a computer could be deemed intelligent. So that word deemed is quite specific there. But in 1955, this was actually when the term artificial intelligence became a thing. So John McCarthy was at the Dartmouth Summer School, where he got together some of the biggest brains in research, some incredibly famous names. I actually have some notes over here. A whole set of different people. Marvin Minsky, I think, was in there as well. We know him very well from the AI timeline. But basically, the idea was this was the quote that came from it. So this was in 1956, so just slightly after. To proceed on the basis of conjecture that every aspect of learning or any other feature of intelligence can, in principle, be so precisely described that a machine can be made to simulate it. So at the end of the day, I would say that's kind of saying the way that we learn, if we can describe it in enough detail, then a computer should be able to do it as well. So it's quite it's a very broad term, right, in research, but realistically, if you think about what we do now, it's not quite what it says, but it sort of is. We've kind of turned off very slightly into the ideas. And then from this time onwards, it became a bit of a time for research, a time for people to push boundaries. And we saw all sorts of different inventions. Unimate, ELIZA, and Shaky are just a selection of a few. Like, definitely go and look into this time, because this time was like cutting edge, right? In 1964 is unbelievable. We created ELIZA. ELIZA was a pioneer in chatbot, basically. ELIZA had all sorts of different functionality in the end, and one of them was a psychologist type approach. One thing that came from ELIZA was not just conversational AI, the idea that we want to talk to people as humans, but also I would personally say there was warning signs of the ethical principles that come into AI, because ELIZA was trying to be a trained professional by repeating basically your questions back to you in an idea that is a way that you sort of think in on yourself and maybe get to different places in your brain of describing maybe why you're feeling a certain way. But realistically, Joseph, who created it, got a lot of feedback, let's call it that, not all positive, on how dangerous this could become. So unfortunately, all of these amazing creations, I think we've lost the slide. There we go. All these amazing creations became very, very popular, but also critiqued pretty highly. And so that's when we drop into what I'm going to call the first AI winter. So an AI winter being, we've promised so much, and we've not quite delivered to what we're promising. There was a lot of people who were putting a lot of money into AI research at the time, including governments from around the world, research institutions, all sorts of different spaces. But after this AI winter, funding kind of ceased, right? And it was, the optimism was lost. We were finding issues with compute power, issues with the amount, what we call combinatorial explosion. So the amount of data points that we can actually process. If you've heard about any of the recent models like GPT-3, they have like billions of parameters and stuff like that. Like we just didn't have the kind of compute power we needed. Data was needed for vision and speech problems. Now that seems like a trivial problem, right? We have too much data, it almost feels like. Whether it's good quality is another question. And then also the ability to frame the question was a problem. And that's why we dove into this AI winter. We weren't able to actually understand what question we're trying to answer properly. And maybe these questions were far too narrow. In the next sort of stages, we saw things like Deep Blue and all of that, where actually we started to see real progression. It actually became a time when knowledge-based systems were incredibly powerful, and they did start to get actually included within business scenarios. They weren't super accessible to, say, like a small business. These were like large enterprises that could afford to take these research projects forward. But realistically, it was definitely a time of, okay, we need to show that we have value. And so a lot of people went down two different routes. So they had something called Neat AI and they had something called Scruffy AI. Neat AI was this knowledge-based knowledge mining type approach where you'd use tree-based kind of decision points. It was quite structured, but it was also incredibly hard to maintain. It had a certain skill set that needed to maintain it, and also incredibly powerful technology. Down the Scruffy route, Scruffy, I love that word kind of for it, was actually more the idea of connectionism, which we now know of as probably as neural networks. And this idea of this kind of more black box model and how it would decide between its different neurons. This was actually something that was very much said like, no, that's not really the approach to go, which obviously we see later on, once we had compute power, became a huge breakthrough for things that we did. And that probably took us more into the kind of the Roomba. So if anyone's got a robot Hoover in their house, do let us know in the chat. The Hoover was an incredible, an interesting one, right? A one that landed in people's households, a one that took AI to the real world and wasn't just for large customers. And then we're getting much, much more closer to home with things like Siri and Watson, where this started becoming a smart assistant. You didn't have to be a CEO of a company to have an assistant anymore. You could literally be anyone, and they're right there on that mobile device that is very integrated into your world. Talking about voice as well, being able to actually interpret audio, understand and context and text. A lot of actually things from within search. I mentioned I worked in search for a while. I would say search engines were a real groundbreaking at the time application of machine learning that really changed the way that we worked with the internet. And as we got into sort of later years of search engines, it's much more around context and understanding. What location are you based in? When you ask for a Jaguar, how do I know you mean the animal or the car? Like, how do I make that decision? Because actually search engines are in most cases, when you're not signed in, very anonymous. And so you can't understand who your user is. And then finally, we're getting much, much closer to today with things like Alexa. Eugene was a chatbot that passes the Turing test. There's been all sorts of claims of passing the Turing test, but also a lot of criticism of passing it to say, actually, is this intelligence or is this not? And so that kind of brings me to my final point on this slide, which is, the key thing about artificial intelligence is I feel the definition has changed as we've progressed. So if Eugene had happened in 1964, where would we have kind of got with that? Or Eugene would have been very, very different application in 1964, would have been more like Eliza, right? That is a long time between those two things. But realistically now, we have a huge expectation of what AI can do. But also we are in lots of areas living up to that expectation and really making groundbreaking breakthroughs. So if you take anything from this, go and dive into the history of AI because it's fascinating. And I do think it has some interesting signals that can tell us a little bit about why we've got to where we are today.
Cool. I love to hear it every time. And every time you add some new little facts, so it's really
do I? There we go. Yeah, it honestly, like I just read about it sometimes. It's always in articles a lot about this as well, like the history of stuff. And so yeah, I'm a big history, but about anything, history of anything I find interesting. So yeah, this is definitely somewhere people should look into.
Yeah, and I should extend this slide with actually 5 more years.
I know, 2017, right? Yeah, we should add in a few more things.
Exactly. So that dives now actually in the question what machine learning actually is in a more technical way. We heard the history of the Turing test when AI was born, what it means. So machine learning, that's a very specific part. Machine learning is the ability to learn your computer something without explicitly programming it. And for me, in the beginning, I got quite lost with what is AI, what is machine learning, and how deep learning fits into that. And there is a great blog post about it. I think Francesca wrote it, one of our colleagues, which you absolutely one time should have on your meetup. But Amy, yeah, you can explain that very well. What the difference is between machine learning and deep learning.
I was going to say, let's keep this one short because I definitely think do take that link and have a good read because it's a great article and it really breaks it down. There's lots of good tables that tell you the differences between different things as well. So do check out that link at the bottom. So docs.microsoft.com, machine learning, and then concept-deep learning versus machine learning. But yeah, so artificial intelligence, right? We talked about the history of it, and we've actually said that the term artificial intelligence tends to change. So at the moment, we could probably say that artificial intelligence is any technique that enables computers to mimic human behavior. So something where we consider it to be acting intelligently. Artificial intelligence is kind of the umbrella term. A lot of people associate artificial intelligence with machine learning. However, something could be AI and actually not include machine learning at all. So do keep it in mind that artificial intelligence is all about the idea that it looks like it's being intelligent and it's a system that can maybe support you, make something more efficient, makes things easier, or acts as we do with each other. So maybe it makes smart decisions about your calendar, or maybe it has a strong conversation with you. But there's also that caveat of obviously how far do we want to go as well with artificial intelligence? And that's a much broader question to be answering somewhere else. The machine learning element, so machine learning being the ability to learn without being directly programmed. So instead, Hank's going to take us through this paradigm shift very shortly. But realistically, machine learning is the idea that we pass a computer lots of data, where we tell it what has happened in this data, and it can then infer future cases. So if we give it lots of pictures of cats and dogs, it can start to generalize, is the idea of machine learning. So when it sees a tabby cat a black cat and a ginger cat in 3 different positions, like sitting, lying, and walking, or something like that. What we want it to be able to do is when it sees a new cat, so like a big white fluffy cat or something, we want it to say it has the features of a cat, and therefore I can understand and generalize. So machine learning is really very powerful and quite a shift in the way that we've thought about programming. And then deep learning being a subset also of machine learning. So not everything in machine learning has to be deep learning. In fact, traditional approaches tend to be very, very effective still. We heard that actually, Hank, didn't we, from one of our other global AI community sessions recently around natural language processing. So check that out if you're interested. So deep learning is the idea of a machine learning algorithm choosing the specific features and the important how else can I describe a feature? The important indications of the question itself. So in traditional machine learning, I would give it columns of data. Like if I wanted to predict a flight arrival time, I'd say, what was the departure destination? What was the arrival one? What time did it leave? What's the weather like? All of these things are features. They're things that could impact the result. With deep learning, which is very, very popular with problems such as computer vision and natural language processing, one of the things that it actually is able to do is it's able to decide for itself what it thinks is the most important thing. However, deep learning can often mean a lot of data is needed. And so, yeah, that just scratches the surface. There's so much more to read on this kind of stuff. So please check out that link at the bottom.
Cool. That brings us to our next segment, because we heard all those approaches mean that we are not explicitly programming our computer, but we give it data, we select an algorithm, and it will come up with this kind of function, this kind of model for us. But how do we know it is making the right decisions? And because all the computer knows is the data we or you have given it. So it is very likely to pick up a biased view of the world, especially when we train these bigger models. We want to avoid that. So would you trust AI?
Yeah, it's a good question, Hank. Would you? I went to this. I cannot take actual credit for this idea. I have borrowed this idea from one of our incredible speakers at Microsoft. And one of the things I kind of wanted to say around this was I went along to this event. I had the opportunity to speak, but one of the things I love about events is I also get to watch everyone else speak as well and hear about their interesting projects. And this one really hit me as something that is quite actionable. It's an interesting scenario, and it's something that you can take away with you, hopefully, to start your journey into ethical AI. And so the question proposed was basically, would you trust an AI too? And so what I want to do in this session, do go to the blog post at aka.ms/ethical-ai-questions. This is the blog post I wrote based on this session that I watched. There's also like a full series of lots of great AI articles at aka.ms/ai-april. One of, cool. So one of the things I want to do first is I want to talk through a few scenarios. I just want you to think about the questions that I'm asking you. Okay, so would you trust an AI to recommend a product or service? Well, yeah, like I'm pretty confident with that. It tends to do a good job. It gets me buying all the time and spending way too much money online. So that's one, right, that we're quite used to now. We're used to that. And it's not super invasive as well, which is interesting. So would you have an AI help you keep you safe online? Well, I know that we do some really cool stuff around security, detecting new threats and stuff like that. And so, yeah, I'd say more than happy for it to help me. It's not something I can do myself, so I definitely want the best intelligence out there to kind of sort that.
Can you still hear me? Because my computer completely froze, but I can only hear it.
Oh, no, we can still hear you and see you, which is very good for...
So you can see it. Okay, that's funny because I can't touch anything on my computer. Everything froze.
Oh, no, you have frozen as well now. So we're no longer seeing you moving. No problem. We'll just take a very brief... Are you okay?
Yeah, I guess so. My screens went out. You started moving again. My screens are back.
Yes. Okay.
Yeah, this never happens.
No problem. This is the greatness of online events, right?
Exactly. Okay.
Perfect. We are back.
Skip the slide. Yeah.
Cool. So thank you, Hank. Sorry about that. Cool. So would you trust an AI to assist your driving? Interesting. Assist, potentially, right? I can't actually park a car very well. So like the sensors and any kind of direction it wants to give me or just do it for me, I definitely take. So yeah, I'm all right with that. So if we, what's the next one here? Oh, interesting. So we stepped it up a gear. Would you trust an AI to drive you? Okay, so right, we know about brands of cars that do have self-driving capabilities that you can turn on and off. So that's become a little bit more mainstream. I see them on the road, and people are kind of getting more comfortable.
Just got one.
Have you? No way.
Yeah, like 2 weeks ago, I got one, and not like the Tesla that's supposed to drive myself, but this one keeps distance to the car automatically.
Yeah.
So it brakes and so on, but it's scary.
Is it? Yeah, an interesting experience, right? But you must have then trusted it in order to opt in and buy it, which is interesting. And so seeing it in mainstream media.
I needed to see it, but there is also a big button to turn it off.
Interesting, right? So like big, obvious, easy to access way to stop it. So, right, an interesting one, right? Drive you. Would you trust an AI to drive you? So what is I think this is our last one. So my last question for you is, oh no, we've got a few more. So would you trust it to monitor your health? Yeah, probably. I mean, the only risk I always think about is data leakage. Like what, if it's monitoring where I go on my run and it's monitoring the GPS from my house, and that data got out and people know averagely what time of the day I go for a run and I won't be in the house, could be some security issues there. But that is like a much wider problem, right, with data in general. It's not necessarily on the AI element of it. It's just that AI has a lot of data to power it. So let's step it up a level, not just monitoring your health. What if it's controlling your health in some way? So what if actually would you trust an AI to dispense medication? Again, not one that I've had to dive into too much, but could be an interesting scenario. I feel slightly more uncomfortable about it. I start thinking about sort of, what if it like malfunctions, or what if it like doesn't do it correctly? How much control do I have? Interesting, right? After what Hank said about the car, I'm asking how much control do I have over it? And then finally, the topic of our conversation, would you trust an AI to choose a babysitter? So let's dive into that one a little bit more. So we are going to do a case study. This is partly based on a true story, but we're going to keep it fairly high level and use company X. But as I said, if you want to see more details, do go into the links. So, perfect. So you are potentially, actually, people watching, you might have young children. this was maybe slightly more before COVID times, but we're in this place where we have young children and we're trying to balance all the things going on in life. So how do you actually choose a babysitter? In the past, it has been all on recommendations, people in your local area, people other people know. But what if you maybe just moved to a new place and you don't really know anyone? You still need some help, right? And so what if an AI was able to go through different babysitters across, your local area or something? And what if they could actually assign each babysitter to a set of different tasks? So this company would do an evaluation based on the social media data of said babysitter. In that evaluation, they would take a lot of the social posts and they would actually then say, okay, let's take those details. And if we skip along just one more.
And it is freezing again.
Oh no, you're killing my story, Hank. But basically, once it comes back, we'll see it. But what if it starts assigning it to lots of different variables? So lots of different, let's call them features or classes. So whether someone has posted about disrespectful or violent content or something like that. What if we could just build all of those bits? That'd be really good. What if there's anything around flagged posts or explicit content? It can start to understand. So it's an interesting idea, right? It is an interesting idea, but there's a lot of potentially ethical issues here and things that you don't first think of when you actually hear of the idea, right? There's probably there was some bells ringing for me where I was a bit like, oh, this seems a little bit strange. But yeah, so is there are we able, is it okay, Hank? Are we still moving? Oh, awesome, we're back. Nice. So yeah, if we just build this slide, that's fine. One of the things that we have to think about when we think about ethics in general is ethics tends to get split into values based on the well-being of others. So things like non-suffering, the ability to have autonomy in your life, and the ability to have equality in your life. And then there's also this idea of values based on your own well-being. So something you want for yourself, which is some form of virtue. So what are the non-negotiables that you have in life, morals type thing, and also trust, having trust of other people, having trust of the people around you, etc. So these are high level. This has nothing to do with ethical AI. This is ethics in general, how we tend to understand ethics. So if we go to the next slide. And so an interesting framework that's currently being used is called the FATE framework. So if you go to aka.ms/GAIB, this was the Global AI Bootcamp, -FATE, then you'll be able to find a lot more information about each of these different approaches. So the 4 different things are fairness, accountability, transparency, and ethical approaches. So if we build this slide for me. One of the things, if we start to consider how company X used the FATE framework, so if we use this framework and we ask ourselves questions about company X, these were some of the things that I came up with when I was thinking about it. And so fairness, is anyone being treated differently is an interesting one, because actually the first thing I thought of was, I was like, but what if a babysitter doesn't have a massive social presence, such as they might be a slightly older generation in society and they have zero interest in being on social media, and does that actually make it harder for them to then be a part of this platform and get work opportunities? Is that the right way to go? Are we discriminating against a certain type of person? Is the training data representative and relevant? If you're using your social media for your social life, is there an element where we should be considering work and social life being two quite separate things, or is it the right thing to consider actually the overall concept of a person in work and life? Are there systems in place to address any of these issues that we talked about? So lots of great stuff around fairness. Accountability, there's some great stuff under here, including if I am not happy with the outcome of this, so say I sign up and it says, actually, Amy, not a great babysitter, you used to travel all the time, you wouldn't be available, you know, all of this kind of stuff, I've got no experience or something like that. Is there a mechanism for me to actually challenge that? Is there, at the end of the day, a human that is accountable for the decision that's being made, or is it purely on the algorithm? And is the behavior of the AI actually useful in the real world? Is that actually how we can interpret someone's morals and whether they're a good person to look after our child? Transparency is another good one. We've talked a bit about data in the previous bit. So is it clear that an AI is being used here? Is it obvious when someone signs up to this system that their data is being analysed and a decision is being made via an AI? Is it well described, as we've just said? Are there any limitations? Because at the end of the day, AI is not necessarily perfect, right? We always know that it's a probability that's often being passed back, or some form of mathematics is being passed back, and it's only as good as the data it's been trained on, or the model or the design in which it's been used to build it. And so actually, is it honest, the system, about where there might be some issues that you could challenge? And also, does it comply with privacy laws? What are they doing with your data? How is that secure? Can you request the data? Can you ask for it to be deleted? All of that kind of stuff. And then finally, how does this impact society? We've talked about people that it could discriminate. Is this actually equality? Is this autonomy? Does this, I mean, you could turn this on its head, right? And say, well, if I did move to an area, does this give me autonomy? Does this give me the ability to understand and get access to people who I can talk to and understand before them looking after my child? Is there any human monitoring? We kind of covered that a little bit also in the accountability category. And then the final piece is there, if lives are impacted, it's important that people understand how the decision was made. So is it transparent, but is it also an ethical decision that's being made, or is there something in there where we might have a slight skew in the data, and it could actually be something that's discriminating and we're not actually sure whether we knew that or not? And so if we go to the next slide, I just thought this was a really interesting approach and an interesting way to describe the FATE framework, right? And so if you're working on an AI project, I highly encourage you to look at the FATE framework, look at those questions and ask those questions of your system as well if you're building. And then as you're building, if you're in the data science space, I highly recommend taking a look at some of this great documentation and learning information about interpretability. Interpretability is quite a new step into ethical AI. It's the start of thinking about, is there tooling that we can use to help us understand and interpret what's truly going on in our models? It's very, very new, and it's by no means, you know, a one hit sort of like, yeah, that solves all our problems. There's a long way to go, but having these considerations, looking into this tooling, are good first steps in some senses. And so, yeah, I think that's mostly all from me. The only thing I wanted to put at the end was the key to ethical AI is that you read up on it, you understand what's going on in the space. I'm not sure if any one person has the right answer currently, if I'm honest. I'd probably say it's more likely that if you have a look around, these are some of the resources I can personally recommend. I've looked through some of these. So The Trouble with Bias is one of my favorite ever keynotes at a machine learning research conference by a researcher named Kate Crawford, who works in this space. And she does an incredible job of explaining what is the issue, where has it come from, this is not a new issue, and we're learning off data that is potentially already biased before we even train an algorithm. Looking for responsible AI resources. The AI Now report, there is a 2019 one, sorry, I need to update that, from the AI Now Institute, is a great document. It's a long document, FYI, but there's a really nice executive summary that will basically talk you through what are the top points that people from all sorts of different domains are talking about, and what we need as a society to move forward with AI. And they have conversations with researchers, legal experts, all sorts of different people in the industry, business, people who run businesses, actual people who use AI, all that kind of good stuff. So yeah, do take these away, maybe take a picture of this screen, or I can probably start putting some of them in the chat as well.
Cool. Okay, that was interesting. I didn't see this part yet. So that was a good explanation. And I think if you already think about it when you're doing AI, you already made the first step.
Mm-hmm.
So that is especially what we're going to talk about now. How you can make these machine learning models. How can you build them? What kind of tools are there? And how can you use, of course, Azure to do this? So first, one more sentence about building vs buying it. So there are a lot of different providers out there. There is Amazon, Google, Microsoft, and they've all built out-of-the-box AI systems for you, which you just pay a small fee, mostly per request or a subscription or whatever pricing model they want. And you can use it without actually having to go through this kind of hassle, maybe, to train it yourself. And you kind of outsource the responsibility of responsible AI to that cloud provider. So if you go and buy these services, you probably find an explanation about this AI, on what data set is it trained on, is it fair, how are they accountable for it. So that is already very useful. And of course, these bigger providers have a lot of resources, like training resources, but also engineers that work on these systems to make them fast, reliable, safe, explainable. If you're going to build your own AI system, if you're going to build like a very complex AI system, you need to do all those things yourself. And it can get quite complicated and expensive. But it is a lot of fun to build it yourself, of course, and to actually understand what is going on. So for simple models, like what we're going to show you later on, is perfectly good to build it yourself. And then we will also answer some AI questions, AI ethics questions about that, which is always fun in that demo context. So let's first move to these pre-built services. With Microsoft, we call them cognitive services. I think with Google and Amazon, you have similar services at the moment. And they're mostly divided in 4 regions. So there is vision, speech, language, and knowledge. So there is vision. It's a set of APIs to make your application see things. There is speech, to make your application talk and listen to you. There is language, to understand what is being spoken. And there is knowledge, if you want to tap into the knowledge of the wider internet. So let's first dive into some things these cognitive services can do. So there is the real-time speech translation API. This API can translate and listen to 10 languages. I think they've added a few more over time. And it can translate to 62 languages in real time. Some of them you can actually listen back in your ear to, and other ones I can just subtitle. And you can even get yourself subtitled real time in Klingon if you speak one of these 10 languages, and actually 2 dialects of Klingon. There is also a face API that will help you detect and describe people in images, and can even be used to identify a person. So the only thing you have to do is grab a frame from a camera, a photo, and upload it to this API. And then this API call, you specify which things you want to get back, but if you specify that you want everything back, it gives you lots of insights about every face in that picture. I think you can actually have around 30 images, 30 faces in a picture at the moment. So first it will tell you where the faces are, where your face is. And then it will tell you exactly where your top left point of your eyebrow is, where the tip of your nose is, where your lips are, where your eyes are. So these are like around somewhere between the 20 and 30 points, but will tell you. So this is very easy to easily to put on someone fake glasses or put on lipstick or put on a funny nose. This is kind of the information the Instagram filters use. But
I
it tells
never
you a bit.
realized I never realized how many things were on here as well. This is obviously like increased. Do you use all of them all at once, or is it a you only use what you need type thing?
Yeah, so in the request everything comes back or not.
I
It
see.
is
And so you would
it's
just
one or two,
extract.
yeah.
Mm.
But this, yeah, it comes back, and it actually, if you just send 30 frames per second, you get like real time where someone's mouth is, and you can actually put on those funny lion faces or a mustache or glasses
Yeah.
and so on. So
Ah,
it
and
is
we know where
very,
that's used in real life, right? Like filters on like Instagram and stuff like that. Like you can see where these things are actually being built on as well.
yeah, and
Ah.
basically to have that power, you actually don't need to do any machine learning. You just
Mm.
send a picture, you get those coordinates back, and then it is just programming. Put the point of this mustache on this X and Y coordinate.
Yes.
It gives you some more insights about every face. Tells you, guess your age, your gender, classifies if you're smiling, can tell you which glasses you are wearing, if you're wearing any, so it can
Mhm.
distinguish between reading glasses, sunglasses, and swimming goggles. So if you put on
Oh,
swimming goggles, it will actually tell you, hey, you're wearing swimming goggles.
wow.
It classifies your hair in all the different colors. It will not tell you, hey, your hair is brown, but it will tell you, hey, I'm 99% sure that your hair is brown, but I'm also 69% sure your hair is black. So it classifies it. Tells you if you have to go, if you have to shave your beard or your mustache or your sideburns. If you're wearing eye makeup and lip makeup, as you see, I left it off that day, and it can tell you which accessories you are wearing. So it's 100% sure you wear glasses, but it can also say if you're wearing a cap, and I think it could say your earrings. But they extend those things all the time. It can also classify your emotions. So it is trying to classify and guess. Oh, I think this person looks happy, neutral, and there are some fun games you can actually do. I think it is even in our intelligent kiosk that you can download from the Windows Store. It's free, and then you have this challenge to make all these emotions in front of your camera. It's quite fun. You might have seen it on Ignite or something like there. And then last, it tells you things about the quality of the image of your face. So if you're going to use these type of images for face recognition systems, if you give your face recognition system crappy images, it will also do a crappy job in recognizing you. So these features that it tells about your face can really help you to put on a gate for what you let into your training algorithm. So first of all, it will tell if the picture is really blurry or the exposure is good or bad, but it also tells you if the person is actually looking into the camera and that you're not suddenly training your model on people that look down. So, and if the eyes are there, the forehead is there, and the mouth are there, because it can also detect if your mouth is like covered. So that is the face API. There are lots of more things to it. So I would, if you want to build a face recognition system, this is like a typical use case, I think, that you're not going to train your own models, but that you're going to use some of these services that are out there. And you might be worried with privacy and so on because of this thing running in the cloud and of latency. So the good thing is that some of these cognitive services are offered in containers. So you can actually download one of these containers and run it in your local infrastructure. The only thing you need is that it can connect to Azure every 15 minutes to send back the billing information, because you still need to pay for every request that is in there. But you can also get like a way higher throughput than that API in Azure can offer you. And it is all locally within your own data center and your own Kubernetes service, what you want. So, but what if you want to make this yourself? There are some APIs that can just detect, this is a fork, this is scissors, this is a cup, this is a plant, but it cannot really specify what type of cup it is. It will not tell me this is a GitHub cup and this is like a plain white cup. So then you can customize this vision service. So by bringing some examples of your own products, you just upload it and train your own custom image, custom model for that. So how does it work? You can train two types of models. You can train a classification model. We'll dive into the two different a little bit later, but classification model where you just upload a picture with one thing you want to identify. So in this case, I want to identify Bart and Lisa. So I can either choose to upload images that only contain Bart and only contain Lisa, or I can start uploading images that is called object detection, where I tag where the actual thing is I want to identify. So here I can upload an image with Bart and Lisa and so on, but then I will have to specify Bart is here in this image and Homer is here in this image. Obviously a lot more work, but the result of an object detection model is actually way more fun than the classification model.
And quick question for the audience, actually, for the object detection. So if you train it to understand when we see Homer and when we see Bart, if Homer and Bart are in the same picture, will it pick them both up then?
Object detection, yes. Classification, it will just be like, it might see Homer, it might see Bart, it's just going to say something weird. Maybe it even says Mr. Burns because of the features get mixed.
That's true. That's true. Nice one.
Yeah, so object detection can detect those multiple things in the image, but you need way more training data for that than for the classification model.
Very true.
So you get your image data set, you upload it to this custom vision service, you click a button, and it delivers your model. So what is classification? Classification is it looks at the image, it runs it through the model, and then it tells you, I'm 90% sure that Homer is in this image. One class. Object detection, however, can actually tell you, I'm 80% sure, 82% sure that Marge Simpson is in this location of the image, and you see it can even go over each other. So this Bart and Marge. But for this model to work, I actually needed like 500 images per class. So 500 images for Marge. Yet for dit, I only needed 50 images to do it actually quite well. Another really cool thing about the custom vision service is that by default, your model gets exposed to an API. So Microsoft take care that it runs and is fast, and you get an API key and you can call it. But you can also pick out these models and run it locally on your iOS device or your Android phone or Windows ML. But even you can get a Docker container where there is a TensorFlow Lite model inside, which you can deploy in your own infrastructure. So the big difference is that the model that Microsoft will host for you is a bit bigger and more accurate than the models you export, actually, at the moment. So let's dive into the first demo. and have a look at how we can create a model with this custom vision service. So this is the portal, customvision.ai. And what you need to do is first create an account, and it will automatically set something up in Azure for you. There is a free tier, but there is also a tier where you have to pay a little bit, but then your throughput is a little bit faster. So let's create a new project. So first, when we create a new project, we get this screen, we have to give it a name. And what we are going to do is we are going to create a classification project, because that will train hopefully within like a minute or two, that can distinguish different Lego figures of The Simpsons. So we choose for classification, and we choose multi-class, meaning a single tag per image and not multiple tags per image. So we will just say, this is Bart, this is Lisa, this is Mr. Burns, and so on. The next thing we need to choose is our domain. So we have general, food, landmark, retail. So if we are training to classify a very special dish I only can make, we choose food. So these are the base models that this class is specializing to recognize my objects. You also see the repeat of these ones here, 4, with compact behind. So if you choose compact, then you're able to export your models. If you just choose general, then you're not able to export them. You can change this always later. So what I mostly do is I will train something on general, and then if I want to export it, I will change it later on to general compact, and I will export it so it can run on these basic platforms or even on my Vision AI kit. So let's choose general here and create it. Create the project.
Well, so just a quick question. So that from the domains, that what that's actually doing behind the scenes is something called transfer learning. So transfer learning is the idea that Microsoft have provided a general data set. This is going to be a great starter for 2. Then, as Henk said, you only needed to use 50 images per class. If you're training a computer vision model from scratch, you're going to need thousands, if not hundreds of thousands of images to actually start training it. So transfer learning, if you wanted to go and spend a little bit more time digging into there, is a really, currently a really good approach to doing solving lots of different problems. And yeah, especially in kind of the real world, it's become really, really popular, and it is used here as well.
So let's add some images. So the only thing I have to do is go to my data set and select what are we going to do today. Let's do Millhouse. And I select, I'm first going to start with selecting a few images, like 24. And I will call this a Millhouse. Upload it. We click add. And what should we do, Amy?
Oh, who else have you got? You've got, can we do Mr. Burns?
Yes, let's do Mr. Burns. We also pick 27 images, 24. Mr. Burns, upload it, done, and add a third class. Let's add Krusty. Always good to have Krusty. And we will upload it. You can do it. So now we have 24 images of each, and we will hit the train button, and we will wait and see. It normally trains within a few seconds on such a small data set, but it can also get kind of lost if your data set is too small. Then it will take extremely long for it to come back with a very crappy model, is what we saw last.
I see.
So now we basically have to wait.
And so when you were choosing your training data, I've noticed like you've taken pictures at all sorts of different angles of these different Lego characters and different lighting and stuff like that. And so variation in these images is really important. If you just have the same setup, that's all the machine learning model will learn, right? So the flexibility in all these different images is really important.
Yeah, because otherwise, if there is always a keyboard with Mr. Burns and always a white background here, then it will start detecting the keyboard and the white background instead of the rest.
Yeah, if anything, machine learning is quite lazy like that. Like it will just pick out the easiest pattern it can find, the quickest pattern.
Exactly. Would it be done? No. So slow today. So let's wait until this model trains. And then I've already done this same one with an object detection project. So I have here all the whole data set, around 50 images per tag. But what I did here is I tagged where this actual Lego figure is for all the images. So this is a horrible job to do. It takes long. It's not fun. Okay, maybe maybe the first 5 images are fun, but then it is not fun. It gives you actually some suggestion where your object already is. It doesn't know what it is, but it will tell you, hey, there is an object here. So you don't have to drag the, like here, like this. Here it detects something.
There are some tools out there that help you with tagging images and finding areas, bounding boxes and stuff like that. And then the output, you can call the Custom Vision API as well and send in bounding box details and stuff like that. So if for anything that you're building in Custom Vision, like it is doable to tag this many images, but again, in models where you're maybe not using transfer learning or you're building your own bespoke models with like different frameworks, often finding some of those tools is important. I'll see if I can find a link and I'll pop it in the chat.
Yeah, I've used the visual object tagging tool.
Yes, that was what it's called. Let me find the link. Object.
So what we can do is we can do a quick test to see if this actually works. The images are still 50, so it is still a small data set. So, but if we upload this one, we see it is able to identify lots of people. So the threshold value should always be at least above 50%. And then here we see it can find Marge, it can find Lisa, it can find Bart, and it can find Mr. Burns instead of Homer. But yeah, they're both bold. So, but this is what you can do with 50 images per tag. So that is kind of cool. So also you've seen me sending this one to the API. What we can do here is we can see all the predictions that are being made. So if you send images to the endpoint all the time, everything is going to be collected here. And what we can do then is we can say, click on this. And we say, no, this is not Mr. Burns. This is actually Homer. And then we can add this image back to our dataset and retrain our model on this. So the next time it is capable of detecting Homer, hopefully, if we give it enough sample images. So now this one is back to the training images, and we will see it here. And if we now hit the train button again, we have to wait like 30 minutes because this model, it takes a lot longer to train. But let's switch back to our model and see if it is already done by now, if it can find my projects. Yes. So here is our Simpson model, and it is still training. Okay. Luckily, we have prepared for that, and I've already uploaded some of the other models. Here we have also a project with Bit or Not, and can detect trash pandas, but I think this one is the model where everyone is uploaded. So what I actually wanted to show you is I need one that is trained with a few classes. It is not the custom visions day. No, okay. So it has
Perfect timing.
trained a model, and here we see it thinks it has trained a perfect model, but actually it didn't, because the data set is so small and the images are so similar. So it tests really against exactly the same images. So we uploaded 24. It probably took like 70% to actually train our model and 30% to score it, meaning that there are like 2 images it is testing against. So then it is quite easy to get a higher score. So here it gives us a warning, and it really tells us we recommend you have at least 50 images per tag. So what we can do is we can upload the rest of these images. So what we can do is we can pick the rest of Mr. Burns. We can add the rest of, who did we had? We had
Millhouse, yeah, and
Millhouse.
Krusty.
We had Millhouse. I think we're here. We had Millhouse. And we had Krusty. Yeah, I guess from here, all nicely different backgrounds. So now I didn't tag these images, but it already has a model that is doing something. I can say get suggested tags. And now it will actually do a prediction with the model that is already inside on these images to tag them automatically for me. And I only should have to press the button confirm tags, and then we can retrain it again. So it is here starting to fill up. So it has found 29 Mr. Burns images. So I can confirm those tags. It has found 31 Krusty images, confirm tags, and it has found 27 Millhouse images. So I can confirm tags, and I can say train, and it will start retraining this model with this new data. And what I will get is I will get a new iteration of this model. So here we have iteration 1. So I can publish this model, resource. So now I have one API here that is actually holding model 1. But I can also publish later on model iteration 2 from this model, and I have another API. So what I can do now is I can deploy both these models and put some A/B testing on it, or send all the images to both endpoints so I can compare which model is actually doing better predictions. Because from my experience, it is not always true that if you give it more data, that the model is actually performing better. So you really want to test this. And of course, you can all automate this even with some load balancers, with some programs you write, because from here on, it is just calling an API. So if you would have chosen for a different type of model, a compact model, then here you would be able to export them. So we're not going to wait another 5 minutes for this. But I hope it is kind of clear what this service can do for you.
Yeah, that was a great demo. Love the suggested tags bit. That's new. I've not seen that before.
Yeah, it can also do it with the object detection projects.
Oh, very cool. Very good.
Then you have to open every image and click confirm.
Okay,
you cannot
I see.
Confirm them all at once.
Mm-hmm.
Like a few months ago. So if you want to do this yourself, there is actually a blog post I've written, and this one also tells you how to do it with Python. So you can use a Jupyter notebook to actually create this. So you can create like a kind of repeatable way of doing this, because uploading things to an interface and click on train might not be the best idea if you do this in a production project. So then you can actually version it in GitHub or whatever source control you use and redo it. So you can break down the project, recreate the project, and it will exactly give you the same results. So this is great. So if you just have a few products, a few things you want to detect or add, then this is your tool to go, because it works very well on a lot of different things. But sometimes you just want to actually train your own model and do it from scratch because you want to have control over your whole pipeline. You control the data, you want to control the algorithm, and you want to control the deployment. And you want to be able to explicitly explain what is going on in your model, and you want to craft your own model because you have data scientists in your team. So let's have a look at first what you have to do to actually get to make one of these models, because it is like completely different than creating software. And especially if you're now working in these mixed teams. First, we had like groups of data scientists creating models, and then those models were something. We see now that it has moved into projects in like kind of ML DevOps teams, because still the name DevOps is applicable here. These data scientists join the team, and the power, of course, from a DevOps team is that you understand from each other what you are doing. So let's go and have a look at what a data scientist actually has to go to deliver us a model which we can use in our bigger software things. So every machine learning project or every machine learning model starts with asking a sharp question. Meaning that if you rethink this, you have to first come up with a question that you want to have answered before you should start creating a model. So if someone comes to you and says, hey, create me some AI, or I want to have this, you can ask your manager or your employer or your client, what is the explicit question you want to have answered? So we always start with it. And there are only a few types of questions machine learning can actually answer. Like, to which class does it belong to? Is it this or is it that? What action should I take? There are only a set of 5 questions you can ask these type of models. If you have your question, you need to have data, because if we switch back to the beginning of our presentation, we could say machine learning can answer questions by giving it sample data. So we need to collect a lot of data. And we all know that data is messy. It is never in the right shape. It is never all true. Never all data points are filled. So it is always messy. So then the big chunk of the work comes in. We need to prepare this data so it can run through our algorithm, because this data needs to be in the right shape, nicely packaged, so it can run through our training algorithms. So we have to prepare this data, and that takes a long time. What I hear mostly is 70 to 80% of a machine learning model, people are busy actually shaping, gathering, cleaning the data before they can actually run and train the model. Is that also true in your experience, Amy?
Yeah, absolutely. Any data science project I've done, that's been a huge part of it. Also, thinking about all of this process as non-linear, because you'll end up asking a question, collecting some data, preparing some data, maybe then going back to collect more data, different data, maybe asking different questions because now you know what's in your data and you actually understand it. So yeah, this is definitely a non-linear approach, but preparing data is a huge one. Also, just understanding your data, it is incredibly important that you are the ultimate expert in exactly what is going on in your data, why you've chosen it, what is your hypothesis of what it's going to predict. Rather than kind of going in blind. We tend to see sometimes that people don't really understand what's going on in their data, and that can lead to really unexpected circumstances. So preparing your data is so important.
Yeah. So this takes a lot of time. And then you have to select an algorithm. So I'm not an expert, but mostly my recommendation is, or what I do is I pick a few. And then I start running them against each other, see which one performs the best. Um, so it is, for me, it is always kind of trial and error between the different types, which exactly fits. And like Azure Machine Learning can run all these models next to each other and give and compare the output on your data. But there is also some automated machine learning kind of systems that will help you actually pick the right model for your specific question on your specific data set, or at least does a guess. So how would you pick a model, Amy?
Good question. I do a very similar approach to you. So if I've already done some stuff in the area, so if I have experience in the project that I'm working on, I probably have a slightly better inkling of what might work. But you've probably heard this term before, well, it depends. And one of the key things it depends on is very much the data that you're providing it as well. So some models will do better with certain types of data. Also understanding if there is telling signs, so if there is predictive power within inside your data set, and an algorithm or a selection of algorithms can give you that insight a little bit better. You know, is it just that a specific algorithm is not great, or is it actually that no algorithms are performing very well and we have to go back through our nonlinear process again?
Yeah.
So yeah, algorithms is I don't want to say it's like a dark art versus a science, because I guess it's not. But one of the things I found is experience. So read, if you're embarking on a project, get Googling, like go see what other people have built, what they've used. It's a great starter place to understand even what you're looking for, and then start adding to that. So if you see two different papers or projects have used different types of approaches, try them out. And as Hank said, the Azure Machine Learning Service is primed to help you with this.
So then when you have the algorithm, we can actually start training the model. And that is what Azure Machine Learning and running at scale, running on GPU clusters, that is actually when you start needing your GPU and start training. And that is mostly not the most difficult part of your whole experience. If you have done that one or twice, then you know how to train the model. And then also never forget to actually use your model and use the answer in the solution, because you get the model, but someone else has to pick up the model and build something around it, so people actually can use it. Even if it is in an API that people can call, there needs to be something that actually uses it. So you need to also, don't forget to write specification on how to use your model.
Yeah, I just add a quick one on that as well. For use the answer, consider this also when you're even right at the start of your project. So when you're asking a question or you're collecting your data, because I've seen a lot of times where someone will design a model and then realize the point in which they want to use this model, they don't actually have the data that they've trained it on. So a good example I always use is, say, a support ticket system. So if you build technology, that you're most likely going to get support tickets for if the technology has a bug or it's not working, or it's got a security issue, or it needs a patch or something like that. People are going to submit support tickets. Now, one of the things, if you wanted to build this into a support ticket system, when the support ticket arrives, remember, you're only going to have basic data about that support ticket to actually start making a prediction. Whereas if you wanted to integrate it at the end and it was more like a labeling task or something like that, or directing it to the right person to investigate further, you might actually have more rich data that has more predictive power in some cases to actually then be able to hand it off to maybe someone else. So always think about where you're going to use this model, because it actually influences how you build it.
Yeah. So we've talked about how to get the data. So now we're going to look at Azure Machine Learning Studio. And this is Azure Machine Learning Studio with a lower S, not a capital S, because the capital S Studio is the old one. And the lower one with the lower S is the new Studio experience, also called Azure Machine Learning without Studio experience. And the old studio with a capital S is now called the Azure Machine Learning Visual Interface, to make it more clear, because naming is hard. So what is Azure Machine Learning? From now, we will call it just Azure Machine Learning. It's a fully managed cloud service that helps us enable all those different steps needed in your machine learning lifecycle. So from maintaining and versioning the data, to training the model, to actually running this model in production and gather feedback so we can retrain our model and do this loop over and over again. And the cool part is that it really helps you to work together as a team, where everyone can see what is going on and can look back at like, hey, how is this model trained? What was the output? What were the parameters used? Which data was there? So we are going to answer exactly the same question as what we did with our custom vision service. Is it Homer or is it March or? So we're going to use the exact same data set and train this same model, but then using Azure Machine Learning. Going to use the Lego data set for if you want to play with that. It's a good data set to actually try out and play with. You have it, it's on my GitHub. You can freely use it. So first, we didn't look at this picture yet, but this is everything on Azure concerning machine learning. So the top layer, the custom vision, popular frameworks, services, and so on. So what are we going to use? We're going to use Azure Machine Learning, this service. We're going to use PyTorch. We're going to use GPUs to train it on, and then we're going to deploy it in the cloud. So to illustrate, we can also pick up the models and run it on-prem. We can also use IoT Edge to deploy these models to IoT Edge devices. So it is quite flexible of what to do, and everything can be controlled and managed with Azure Machine Learning. And it also illustrates that Azure Machine Learning is not bound to a very specific framework. So if you want to train a TensorFlow model, it's just fine. PyTorch, it's fine. It's really what your preference is and which framework will work best to actually solve your question. So this is what we're going to build. We will start off with looking what a data scientist has to do. So mostly a data scientist will use Jupyter notebooks or something similar. We will force it to use some kind of version control because that is what we want. And then it's going to use Azure Machine Learning to train a model and deliver that model in a service called model management. We will dive in later what that service actually does, but you can compare it with like the NuGet repository for models. So when the data scientist is done with training the model, it uploads the model to model management. And everyone else can connect to model management, say I want Hank's model version 2, pull it out, and then use it. So that is where the developer comes in. The developer will pick out the model for model management and probably wants to use the tools that the solution is already made in, because the machine learning model is most likely a small piece of this whole system. And I think Amy's example about support tickets really illustrate that. It is a model that does a very specific task within this bigger picture. So we cannot make that our developer is going to use the same Jupyter notebook as the data scientist. So I always see the model as a function that is published in a repository and you pull it in. Same as a NuGet package that can do like time zone conversion. I pull that package in. I don't know exactly how it works, but I know how to use it. So that is how I see models. This model will do a specific thing for me. I trust the data scientist that it is tested and trained the model, but in my solution, it is just basically a function. I shoot an image in this case for the Simpsons, and I get the prediction out. And I will write software that is will run fast and reliable and so on. So as a developer, I'm likely to deliver a piece of software that will most likely go to a build pipeline and ends up in an Azure Container Registry as a Docker container. And then our operation teams can pick out these Docker containers and just deploy them like the way they normally deploy Docker containers. For them, maybe they need to have some GPU or some access specifications to make this model run faster. But there is nothing more to it than just deploying a container. that by coincidence contains a model. And that can run in Azure Kubernetes service, on-prem, AKS, doesn't matter. And then our client can, of course, connect to this Azure Kubernetes service and enjoy the whole benefit of scalability and everything there. So what is Azure Machine Learning? And here it is called service because names are confusing. So what is Azure Machine Learning? So Azure Machine Learning is a set of cloud services. So it is not just one specific thing. If you install Azure Machine Learning in your Azure subscription, you get a lot of components that work together. So you get a blob storage device, you get a key vault, you get a container registry, and you get the actual Azure Machine Learning workspace. And that is all wrapped up in this Azure Resource Group. And you can control these Azure services with a Python SDK, with the Azure CLI, and you can, of course, use a visual interface. And this set of Azure services helps us to prepare data, manage our models, check our experiments, and actually deploy them. So to get started with Azure Machine Learning, you need to go to 3 phases. So first, you need to prepare your environment, set everything up so it works. Then we need to experiment with our model and with our data. And then when we're happy with our model, we can deploy that into production or dev or test or whatever we want. So preparing our environment. We can do that in multiple ways. We can go to the Azure portal, click, click, click. We can go to VS Code, install AI tools for VS Code, right click, install, create this environment. We can do it in a Python, in a Jupyter notebook using the Python SDK, just write it in code, or we can even do it during using the Azure CLI. So many different ways. I always prefer the ways that are not like click, 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 so everyone can kind of recreate what you're doing. If someone press delete in Azure, that there is like some way of actually recreating your environment. So I would always do it with the Python SDK or with the Azure CLI and then document the commands I've used. If you want to do it from the Python SDK, with the Python SDK, you just have to install Azure ML SDK on your machine. And then you can start typing workspace create, give it a name, point to your subscription ID, point to your resource group, and then specify your location. Specifying your location is already the first important step that you have to consider if you're deploying this. And why? Later on, you're going to need compute. Probably you want to have some GPU clusters. And these GPU machines are not always available in every Azure region. And if you don't create it in the right region, you will actually need to recreate your workspace in the right region where those GPUs are. So it is worth looking at the regions and already pre-choosing your compute type before you actually deploy it. So what you can do is, when you have done this and your workspace is there, you write out a config file. You say workspace, write out a config file. This config file you can check into your Git repository because there are no credentials in it. It's just a pointer where your workspace is. And everyone else who checks out your Jupyter notebook can say workspace from config. And then it will automatically connect to your Azure subscription, pops up with your credentials, and authenticates for you. So this is a really easy way of sharing this workspace with each other. And this is what you get. So you go to ml.azure.com and you will get your machine learning workspace or studio or service, whatever you call it. This is what you get. It is a separate experience outside the Azure portal. So they're slowly migrating all the functions and deprecating them in the Azure portal, and they are now manageable here. So this is the place to go. So let's dive into these kind of things you get. So first, we have data sets. Here we manage our different versions of our data sets that are stored on data stores. We have experiments. Every time you train your model, it generates a new run. In Azure Machine Learning, it was called, in Custom Vision, it was called differently. it was called an iteration, and
Yeah.
here it is called a run. And everything is versioned under that run. All the logging, all your training scripts, all your outputs, everything is there. Then we have models. This is the model management part I was talking about. Here you can register your model and version it. We have endpoints, and there are two types of endpoints. There are real-time endpoints. This is where we can find our deployed models with the software around it. And there are pipeline endpoints. So what you can do is you can create training workflows, and they consist of all different steps, and combined it is called a pipeline. You can publish one of these pipelines, and then it exposes an API endpoint for you, which you can just call, and it will just train for you automatically. And then there is compute. This compute, here you can manage your different types of compute. So the type of compute where you can run your Jupyter notebooks on, where you can manage your training clusters, but also can manage your clusters where your models live in. And then there are data stores. And under data stores, you manage the actual connection to your to where your data is. So here you manage all the credentials to your SQL server, to your data lake, to your blob storage, so that everyone in code can just say a reference to a data store without typing any credential. So now we have our workspace. We have this thing created. We need to create compute. So here I say Azure Machine Learning Compute. This is the provisioning configuration. Take a standard NC6 machine. So it is a standard machine. It is N, NVIDIA, C optimized for compute. So you have NC and NV machines. So NV are optimized for if you want to do streaming and run OBS in the cloud. And C if you want to train machine learning models. And the 6 is the amount of cores CPU cores you get, not the amount of a GPU cores you get. So if you have an NC12, you get 12 cores for your CPU, not for your GPU. So this is the cheapest machine there is that will actually perform and does a very well job. It is 600 euros a month if you don't put it off. But normally you need like 5 or 10 or minutes or a few hours to train it. So if you pay attention here, I see minimum nodes is 1 here, meaning that this machine will always consume my credit card. And I'm out, or Microsoft is out $600 a month. So if you want to just spin up machines when you need them, you put there 0. And then after 120 seconds, it automatically shuts down if you don't do anything. But every time you train, you have to spin up your cluster and you have to add 5 more minutes to your training run. Third thing you need is a place for your data. So you need to attach some storage. This can be the default storage device that you have, but it can also be any blob storage in Azure. Just give it an account name and account key and it will connect to you. So let's have a look at a Jupyter notebook that is actually doing this for us. So this is the notebook. You can also download it from my GitHub later. So I always started putting all my dependencies on top. Other people don't do that, but I do it. So the rest of my notebook is a little bit clearer and we don't have to look at all these import statements. So I've installed the HTML SDK and I'm running this notebook locally. Now I'm going to connect to the 4 things I need. So I need to connect to my workspace. I need to connect to my compute target. I need to connect to my default data store. That is what I'm using. And I need to connect to my workspace. So I'm connecting to that. So my workspace is called Cybertron. We have Optimus Prime as a CPU-enabled cluster. My default data store and the experiment is called Simpsons PyTorch. Second thing I need, now I've created all, connected to all this, I need my data. So I've made it easy and you can download this data set from GitHub. So we download it, we unzip the data set and we upload the data set to our data store and we call it Simpsons Lego version 3. So now it is uploaded to my data store and it is not yet a data set. So what I next can do is I can create a file data set from the images on my data store. I register that data set, and then later on I can connect to that data set. So if we go to Azure Machine Learning, we can go to dataset, and here we find our Lego Simpsons dataset version 3 back, which is stored on our data on our workspace blob data store, and we have version 3, version 2, version 2, and it's created on May 30 and modified on October 15. There's some hints how we can connect to it. We can explore it. Don't know what it's going to do. Oh, this is new. Pretty cool. You can actually take a look now. That didn't work before for a file data set, like yesterday. So that's pretty cool. So here we see it is exactly the same data set as what we used when we were using the custom vision. We can create a new version and so on. So now we have our data there. We can also preview it. We run it, pick some random images, and here we see it is exactly the same. So we have prepared our environment. We have a workspace, we have compute, and we have data. So now it is actually time to do the fun thing and build our model. To do that, we need an experiment that will keep track of all our training runs. When we have created that experiment, just a line of code, it's just a hole, we need to create a training file. It can be any Python file, basically, that you run. So what you do is you write how your model has to train, and Azure Machine Learning will execute the training file. And it will execute the training file using a script run configuration. So what does that mean? So first we start with defining the environment where this training script has to run in. So if we have a PyTorch script, then we can do two things. We can use a curated environment. These are the environments that are maintained by the Azure Machine Learning people at Microsoft. So we can just say, pick out this environment, clone it, and give me my PyTorch 1.6 GPU configuration. Or we can create one from scratch by specifying the base image. You can basically get an Ubuntu base image, and then you can start installing all different packages using the pip package manager or the conda package manager. And what this will end up is this will end up in a Docker file, which will deploy it to your cluster. So basically what you're doing is configuring the Docker image where your training script is going to run in. So when you have specified your environment, you need to specify how your script is going to run in. You can parse some arguments, like where you can find the data, how many training rounds it has to do, and some other parameters. It can be a very big list. You have to specify where it can actually find your training scripts, and you specify on which compute target it has to run and which environment it has to use. So when you have this script run config, you submit this configuration to your experiment. It will start building this Docker container for you, snapshots, everything, and it will eventually will start executing your training script. And there is a widget, and that widget enables you to connect to your current run and get back all the information. So you can add some extra logging, so you can follow the training and the training loss, and so on. Everything you print to the screen will come in your driver's log, so you can follow it real time. You don't have to, because you can connect to it later and look back, but you can see also over time how it goes. So let's train it. So this is my training script. So you might wonder where I actually got this training script from. So I went to the PyTorch website. I looked up the sample transfer learning for computer vision, went to GitHub and copied the script. And I pasted it here. I removed a few things because I didn't want to evaluate and visualize the models because I just want to train the models. So what I did is I added only like 3 or 4 things. I added some references to be able to parse incoming arguments and a reference to connect to my current run. Connect to my current run context, parse the incoming arguments, and then from here, the script is exactly as the PyTorch sample script. The only thing I did here in the training rounds is added some logging. So what I do here is I log a float, which tells me the current loss and accuracy of this of the specific training round, and I log that under the same variable name. And if you log floats or integers under the same name, as your machine learning detects if there are multiple, it will detect that and will start automatically drawing graphs for you. And finally, one thing you should never forget is to save your models in the outputs folder. If you don't save it in the outputs folder, it is not copied back. And remember, this thing is running in a Docker container on your cluster that will shut down. Shuts down, detach your Docker container, everything is gone. So don't forget to save it in the outputs folder, because everything in the outputs folder is automatically copied back to your experiment. So we write our training file, and we can just, because this is a very basic training script, I got it from a sample website from PyTorch, we can use the default image. And I don't need to install anything extra on it, just the 1.6 GPU. I have my incoming arguments. Here I parse, here I use my Simpsons data set, my data set. I give the name Simpsons and smount. And this means that now this directory, this data set is mounted as a virtual directory within that Docker container. So my training script just looks at the images in a virtual directory like if they were there. And you don't have to do anything for that. This is just it, and it knows. It's perfect. So here I tell where it can find my training script. This is where we actually wrote this training script, and it copies over everything that is in that folder. So if you have extra files, you just put it in that folder. Compute target, environment, and arguments. So let's do this. Here I submit my experiment, and here my widget is actually going to see what is going on. And it will start training, and it should be done within like 2 minutes. Picking up my training script and deploying it. So let's go back to the presentation and have a look at what is going on. So we have this Azure Notebook, and I submitted this thing to my my estimator, my configuration run, to the experiment. At that exact moment, it snapshotted my folder with the training script and copied it over. So it is all versioned under that experiment. Created the Docker image. So either it picked it out from a curated image and put it in my container registry, or it created a new Docker image from my configuration and put it in my container registry. It's building this Docker image, and then it is deploying that Docker images to that compute target. It mounted all the data stores I referenced, and then it launched the training script. And then it started streaming out all the logging file back to the experiment where it is always versioned. And if I had a widget running, I could actually follow that real-time logging in my widget. And then finally, when the training script is done, it copies over the output and shuts down the Docker image. Then it has created the model, and hopefully it put the model in our outputs folder. Then the final thing I have to do is to say run, register this model, this is the name, and here you can find it. So the model is running, and we are actually deploying it. It's actually recreating a new image that is perfect. So what we can do is we can actually go to Azure Machine Learning here, and we will see the previous run I did this morning before. Run 50, it is even cute. run 50. Let me see here, it took like 4 minutes and run on our compute target Optimus Prime. So it's run number 50. And one important thing I want to highlight is that from here, from this experiment, it is automatically linked to the data set I've used. So you can very easily go back, click on this data set and see, okay, these files were in there of why the model is behaving like that. What I've done is I've already registered the model from that run. So I can also go from this run to the model it had delivered, model number 42. And from this model, I can also go back to the experiment and to the very specific run ID that it has generated. Now, this is running. But you see here, we're now at training round 6. And here you see real time, this graph's evolving. I think I've put like 15 training runs. So that should be done very fast because we're running on a GPU machine. And here you can pick the different types of log files. So here we see that the accuracy and the training validation are put out. And here we see them all in the graphs. And this is a very small data set. That is why validation accuracy is almost always 1. So we wait a little bit, still have 4 minutes, we can do it. And we can also actually deploy it in 4 minutes to an AKS cluster.
Just going to drop a little snippet of information whilst it's finishing off. So
Yeah.
We always get asked the question, so what deep learning algorithms can I use in Azure Machine Learning? And in this case, it is anything that you can have from GitHub, from PyTorch, Keras, TensorFlow. It doesn't matter. Microsoft isn't creating a deep learning framework here. What we're creating is the end-to-end platform that's going to allow you to create, run, experiment, and deploy. So any algorithm you want to use, it's almost like it's almost not a question. You can use it as long as you bring it into that script run config, and you also obviously have the imports within your training script.
Exactly, yeah. So our model is done, 4 minutes and 20 seconds. And we can actually now register our model. So here I specify a little bit more. I specify the resource configuration, the preferred configuration where my model has to run in, the framework version, and here we can make some extra. So let's test, let's do test 42. And we register our model. Now we have version 43. So we want to see if this model is actually doing something. So I can say model download. It is now overwriting the model that is already here. And this is what I'm talking about. This is the script that is actually loading in the model, going to the labels, and then as a function of scoring. So the first thing it does is transform the image to the exact same shape as that the model was trained on, check if there is CPUs or GPUs, do the prediction, and then return the label. So let's run it on our test set of 10 images. That is new. Did I type somewhere something?
No, I don't think so.
Did I add? Download it again. Hopefully it will do it in the Yeah, I think my graphic card crashed a few times during this presentation.
Oh, yeah. Sorry, yeah, because it's on localhost, isn't it? Yeah.
Yeah,
maybe
yeah.
that makes sense.
Okay. Kind of a downer, but yeah. Okay, so let's go and wrap it up with how you can deploy this. So what we've done now is deliver this model to model management by creating a training script, specifying the configuration it has to run in, and actually run it. So deploying it to somewhere, you need the model, a script that loads in the model and does predictions, and you have to specify an environment where your model is going to run in. Combine these three, and you get another Docker image with your model in and expose it as an API. The scoring script has to do two things. You have to load in the model. Loading a model takes time. And then we have to run. Then we have to actually have a method that is called on every API request that does the evaluation on the incoming data. Environment file is exactly the same as what we saw when we were specifying the environment where the training model has to run in, where your training happens. And then we combine these things in an inference config. So not a script run config, but an inference config. We specify the runtime, which scoring script it has to use, and which environment it has to use. And then we can deploy that inference config to an Azure Container Instance or an Azure Kubernetes service. Deploying to ACI, specifying how the ACI should look and which model we have to deploy. AKS is connecting to our AKS compute, which you need to have linked in your Azure Machine Learning service. And then we can actually do it. So what we're going to do is here we have an inference script that will load in our model and does the predictions. And then we specify our environment. So here I'm specifying a very compact environment from scratch. I say we need it's called Simpsons Inference Config, and just install these few packages for me. So I create that, and then I create an inference config just telling use this scoring file in this environment. Then for ACI, deploying ACIs takes like 5 to 10 minutes. So we're not going to do that. We're going to look at how we can deploy it to an Azure Kubernetes server. So my Azure Kubernetes service is called Exodus, and I'm going to create a deployment configuration with 1 CPU and 2 gigabytes of memory. And we will say test 6. So let's deploy this model that we just have built to this instance. So I'll now start picking my environment and putting in the model, putting in my scoring script and deploying it to an AKS service. And what we can do here is we can later on connect to this AKS service and see if it is actually where it is, what the scoring URI is, and which keys we can use. So I can already go here and we can go to our registered model. Our registered model was 43. Here we see that this is our tag, and we can go to, first of all, artifacts. Here is our model, and we can see the endpoint. So it is already showing us that it is that this is the endpoint. I don't think it is ready yet. No, that went fast. Yeah, deploying to AKS goes really fast. So here we see our scoring URL, and these are our keys. So feel free to try and send a Simpson image to this endpoint. So here we see also the endpoints. We can click on it, and here we can see how it is deployed. So per default, it makes like a scalable solution for you with minimum of 1 replica. It can scale up to 10. These are the thresholds. Refresh period is 1. There's a Swagger URL here. We see even which GitHub repository backs it, that it is healthy, and so on. And it will tell us how to actually consume this model. And recently added, it shows you the deployment log. So if anything doesn't deploy, you can now actually debug it without connecting to your AKS service. So because this is not running on my machine, it should work. So here I have 10 test images and a small script that will send these images to my AKS service. So you can actually use Postman or something to send it, but you can also use this service and then you bypass the authentication because it will do that for you. So let's run it and let's see that we can actually, it's now posting 10 images to that endpoint. And here we see that it is Krusty, Bart, Homer, and Lisa and Marge. It detected these 3 Simpsons well, and this is actually the model that we just trained in those 4 minutes using Azure Machine Learning from data to now running here in an AKS service. So these are some links which came by in these presentations, how to do custom vision, Azure Machine Learning basics. So The demo you saw now is located in my Henke repository as machine learning PyTorch. But if you want to create from this pipeline project that will actually manage this whole life cycle for you and can be controlled by Azure DevOps, it is there. And of course, the data set if you want to play with that. So I think we are done for today.
Very good. Covered so much.
Yes, and so long. Hi, Watson.
Nice. That's brilliant. That would be so useful. And yeah, as Hank was showing us some demos, that gave me a little bit of a chance to answer some of your questions in the chat as well. So hopefully that's given you some more links and just useful advice. So yeah, I hope you've had a good session.
That's good.
Yes. Thanks,
Thank you for having us.
everyone. We'll see you soon.
Bye.